right, welcome back, Math 85 students. So the last time that we left off, we had just introduced what fractions were. So if you recall, a fraction is a number of the form a over b. B is the denominator. That tells you the number of equal-sized pieces that make up one whole. And a is the numerator. That tells you the number of pieces that are shaded. So here's an example. The whole is a circle. I've got two equal-sized pieces, and one of those pieces is shaded. So this is the fraction 1/2. So notice if I go in here and I chop this in half, introduce another cut, I now have 4 equal-sized pieces, and 2 of them are shaded. So really, and I haven't changed the fraction of the whole, which is shaded. I haven't changed the shaded part at all. So this really is the same as the fraction 4 equal-sized pieces, 2 of them are shaded. Now, using arithmetic, how do we go in between the numbers 1/2 and 2/4? I know that they're the same, but in order to convert between them, I could, by introducing this cut, multiply the denominator by 2, because now I have 4 equal-sized pieces. And when I do that, that also multiplies the number of pieces that I have shaded. So multiplying both the numerator and denominator by the same quantity gives me the fraction 2/4. And to go backwards, doing the inverse of multiplying, I could divide both the denominator and the numerator by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. So you can reduce the fraction 2/4 into its simplest form, 1/2. All right, let's do that again with the fraction 2/3. So again, here is my whole. I've got it broken up into 3 equal-sized pieces, 2 of them shaded. This is the fraction 2/3. Now I can go ahead and chop each one of those pieces in half. Now I have 6 equal-sized pieces, and 4 of them are shaded. So that simplifies to 4/6. And notice that we can always, if we had started with the fraction 4/6, we could always divide by 2 in the numerator, divide the denominator by 2 to arrive at 2. 6 divided by 2 is 3, 2/3. All right, so let's see what that means in practice. We have the equivalent fractions property. So if you have a, b, and c numbers with b and c not equal to 0, because of course you wouldn't want 0 in your denominator, the fraction a times c over b times c is equivalent to a over b, which basically tells you that since you have this common factor, this c, which is being multiplied times the denominator and also times the numerator, you can basically divide the numerator and denominator both by c to cancel those c's and arrive at a over b. Let's see how this works in an example. This is example 4.20 in your book. Simplify the number negative 18 over 24. So first of all, because the number is negative, it's going to be to the left of 0 on the number line. So when I simplify it, it'll still be negative. Now 18 over 24, I know that the number 6 is a factor of both 18 and 24. 18 can be written as 6 times 3, and 24 can be written as 6 times 4. So I isolate that a common factor of 6, divide the numerator by 6, divide the denominator by 6, and that reduces my fraction to negative 3 over 4. Let's see how this works in another example, one which contains variables. So I'd like to this is 4.23 in your book. Let's simplify the fraction 5xy over 15x. So first of all, notice that there's a common factor of x in both the numerator and denominator, and also the coefficients here, the number part, there should be a common factor of 5. So let me rewrite these so that I see all the factors. In the numerator, 5 times x times y. In the denominator, 15 could be written as 5 times 3, and then I have my times x. So now I'm going to go ahead and notice that this is times 5 and times 5 in both the numerator and denominator. I can go ahead, divide by 5, divide by 5. Same thing with the x's, times x, divide by x, divide by x. So now what I have left in the numerator is y, and what I have left in the denominator is just a 3. All right, let's move on to another example, which is a little bit more, it has a little bit larger numbers for my numerator and denominator. Let's simplify. This is example 4.22 in your book. Simplify 210 over 385. So first, these are pretty big numbers. I see this one ends in 0, that one in 5, so 5 is likely a factor. Let me go ahead and factor these numbers all the way so I can really see what they have in common. 210 could be written as 10 times 21. And 10 can be factored as 2 times 5, where both 2 and 5 are prime. 21 could be written as 3 times 7, both prime numbers. So now let me go ahead and rewrite the number 210. It could be written as 2 times 3 times 5 times 7. And the number 385. I know 5 is a factor because it ends in 5. And it's actually 5 times 77. 5 is prime. 77 can be broken down 7 times 11. Those are both prime numbers. So I'll go ahead and rewrite the number 385 in its prime factorization form. And now I recognize that the numerator and denominator both have a common factor of 5. See this times 5 times 5. And 7 times 7 times 7. So I'll go ahead, divide by 5, divide by 5, divide by 7, divide by 7, and see what I have left. In my numerator, there's a 2 times a 3, which is 6. And in the denominator, it's just a little. See, if everything is crossed out and you don't see any factors left, there's always an understood factor of 1 there. So if it looks like everything's crossed out, there's always a 1, factor of 1. All right, so let's now move on to what I'll call a non-example. This is an example that people get wrong many times. Let's simplify 3 plus x divided by x. So 3 plus x over x. So a lot of people see that there's x's in common and they just really want to cross them out. However, this is already simplified. It cannot be simplified because x is not a factor of the numerator. Notice up here, all these numbers were factors, meaning they were being multiplied. Down here in this example, x is an addend. It's being added to the 3. So you're not really able to cancel those x's just yet. There's some other things that you could do to manipulate this, but right now you can't cancel the x's because the x is not a factor of the numerator. Instead, it's an addend. All right, what I'd like you to do now is work on this next example. It's example 4.21 in your book. Simplify the number negative 56 over 32. Go ahead and pause the video here, and then I'll give you the solution in a second. All right, welcome back. Hopefully you recognize it's a negative number. The negative sign stays. 56 could be 56 and 32 both have a common factor of 8. So 56 is 8 times 7. 32 can be written as 8 times 4. So common factor of 8, divide by 8, divide by 8, and you're left with a negative 7/4. Nice job.